What is a modulo-N counter in digital electronics? Imagine a digital circuit that counts up to a certain number and then starts over again. That's what a modulo-N counter does in the world of electronics. It's like a clock that resets after reaching a specific number, keeping everything in sync. These counters are everywhere, from digital clocks to computer systems, helping manage timing and counting tasks. A modulo-N counter is a special kind of sequential circuit. It counts through a set number of states, called N, and then resets back to 0. For example, if N is 10, the counter counts from 0 to 9, then goes back to 0 on the next clock pulse. This cycle repeats over and over, making it perfect for counting things like seconds, minutes, or even pulses in a circuit. To build these counters, engineers use flip-flops, which are tiny devices that store one bit of information each. The number of flip-flops needed depends on the value of N. For example, to count up to 10, you need at least 4 flip-flops because 2 to the power of 4 equals 16, which is enough to cover all 10 states. If N is a power of 2, like 4, 8, or 16, the counter naturally counts all binary combinations of the flip-flops. But if N is not a power of 2, additional logic is added to reset the counter when it reaches N. There are two main types of these counters. Asynchronous counters, also called ripple counters, connect flip-flops so that each one triggers the next. This causes a ripple effect, which can slow things down because each flip-flop must wait for the previous one to change. Synchronous counters, on the other hand, have all flip-flops triggered at the same time by a common clock signal. This makes them faster and more reliable, especially in high-speed circuits. The value N can be any number, not just a power of 2. When N is a power of 2, the counter counts all binary states of the flip-flops. When N is not a power of 2, the counter uses extra logic to reset itself at exactly N counts. This is useful for applications like digital clocks, where counting from 0 to 9 is needed for each digit. In electronics, these counters are essential for dividing frequencies, timing events, and controlling sequences. For example, a Mod-10 counter is used in digital clocks to count seconds or minutes. They also serve in control systems where specific counts trigger actions or signals. Designing these counters involves choosing the right flip-flops, calculating how many are needed, and adding logic to reset the count at the right time. In simple terms, a modulo-N counter is a counting device that repeats after N counts. It's built with flip-flops and logic gates, and it helps keep track of numbers in digital systems. Whether for timing, counting, or dividing signals, these counters are fundamental tools in digital electronics.